Hello everyone. Today we're going to cover the Pythagorean Theorem. It's a very important topic in geometry and it's really needed to understand how to do triangles. So let's just start doing it. So what we have here is a triangle that I drew. There are three sides to a triangle. Two of them are called the legs. One is called the hypotenuse. The hypotenuse is opposite the 90-degree angle, which is the largest angle in a triangle. That's a right triangle. And the other two sides are called legs. And how they relate to the Pythagorean Theorem is that if you have a right triangle, and you know two of the measures of the sides, you can find the measure of the third side using this simple formula here. So why don't we just get into some basic problems and I'll show you how it works. So I'm going to draw a triangle here, and let's do the first problem. So let's just say this leg, the length is 3, and we'll have the hypotenuse equal 5. And we'll just call the side B for now, since we don't know what it is. Using the Pythagorean Theorem, we can find the measure. So let's just set up using the formula. We'll do 3 squared plus B squared, since we don't know what B is, equals 5 squared, since we know what the hypotenuse is. We're just going to do some simple algebra. We'll do 3 squared is equal to 9, plus B squared equals 25, which is 5 squared. And now we're just going to simplify the terms. B squared equals 16. That's 25 minus 9 is 16. We're going to square root each thing. B is equal to 4. So in this example, it's just a very simple problem. A 3, 4, 5 triangle here is what I did, and that's a pattern that will always work. And now, let's do another problem. I'll just erase this here. So this time, we're going to know the length of the two legs. So we'll call this leg 5, this leg 12, and we don't know the hypotenuse, so we'll put in C. So using the formula, we'll do it again. 5 squared plus 12 squared equals C squared. So now, just follow simple algebra rules. 25 plus 144 equals C squared. 169 equals C squared, square root each. 13 equals C. So at this point, you might be thinking that you need whole numbers to work with the Pythagorean Theorem, but you don't. You can actually use irrational numbers too. So I'll do an example of that too. So this time, we're going to know one leg and the hypotenuse. So we'll say this leg is equal to 2, and the hypotenuse is equal to the square root of 5. Now, to find A, which is missing, that's the side we don't know, I'm just going to use the formula again. A squared plus 2 squared equals the square root of 5 squared. We're just going to do simple algebra again. A squared plus 2 squared, which is 4, equals the square root of 5 squared. And using algebra, we know that the square root of something, if you square it, you get the original term inside the square root sign. So the square root of 5 squared is equal to 5. And then similar to the first example we did, we're just going to subtract 4 from 5. A squared equals 1. And square root, and of course the square root of 1 is 1. And now, just to end the video, I'm going to give you guys a few of those what are called Pythagorean triples, which are numbers, like the first two problems that I did, that will always work in the Pythagorean Theorem, and it'll just help you guys save time when you're trying to figure out the lengths of sides. So one of the Pythagorean triples is 3, 4, 5, with the longest side being the hypotenuse, and the shorter sides being the legs. Another one is 5, 12, 13. And another one that we didn't cover in this video is 8, 15, 17. And you can multiply these by any number, and you'll still get Pythagorean Theorem formula that works. Thanks for watching the video, and check out all of our other ones too.